Hi everyone, I am Shaktir, Assistant Professor, Hindustan College of Engineering and Technology, Coimbatore, and today we are going to see about the properties of concrete. The various properties of concrete that includes the grade, compressive strength, characteristic strength, tensile strength, durability, creep, shrinkage, unit weight, modular ratio, and also the Poisson's ratio. And the first property is the grade of concrete. The concrete has been known by its grade when it has been designed as an M15, M20, etc., in which the letter M refers to the concrete mix and also the number 1520 denotes the specified compressive strength, that is the characteristic compressive strength of the concrete of a 150 mm cube at the 28 days, and it has been expressed in the form of a Newton per mm square. Thus, the concrete has been known by its compressive strength. The M20 and M25 are the most used grades of a concrete, and higher grades of concrete could be used for a severe, very severe, and in extreme environments. Compressive strength of the concrete, like a load, the strength of the concrete is also the quality, which varies considerably for the same concrete mix. Therefore, a single representative value known as a characteristic strength has been used. And characteristic strength of the concrete, it is defined as the value of a strength below which is not more than 5% of the test results are expected to fall. That is, there is a 95% probability of achieving this value, only 5% of not achieving the same. The characteristic strength of the concrete in a flexure member is taken as a 0.67 times the strength of the concrete cube, and the design strength and the partial safety factor for the material strength, and the strength to be taken for the purpose of a design is known as the design strength, and it has been given by design strength is equal to characteristic strength divided by partial safety factor of the material. And the value of the partial safety factor depend on the type of the material and upon the type of the limit stage. And according to the IS code, the partial safety factor is taken as a 1.5 for concrete and 1.15 for steel. And the design strength of the concrete in a member that has been equal to 0.45 FCK. That FCK is the characteristic compressive strength of the concrete. The tensile strength of the concrete, and it is estimate of the flexural tensile strength or a modulus of rupture or cracking strength of the concrete from the cube compression strength that has been obtained by the relations of an FCR is equal to 0.7 FCK Newton per mm square. And the tensile strength of the concrete in a direct tension is obtained by the split cylinder test, and it has been varies between 1 by 8th to the 1 by 12th of the cube compressive strength. Next one, it is the creep in a concrete. The creep is defined as the plastic deformation under the sustained load. The creep strain depends primarily on the duration of the sustained loading, and according to the IS codes, the value of the ultimate creep coefficient has been taken as 1.6 at 28 days of the loading. Shrinkage of concrete, and the property of diminishing in volume during the process of drying and hardening is termed as the shrinkage, and it depends mainly on the duration of the exposure. If the strain is prevented, and it produces the tensile stresses in the concrete, and hence the concrete develops its cracks. The term modular ratio is the ratio of modulus of elasticity of the steel to the modulus of elasticity of the concrete. And the term modulus ratio is ES by N EC. ES is the modulus of elasticity of steel, that is 2 into 10 to the power of 5 Newton per mm square. And EC is the modulus of elasticity of the concrete, that is 5000 root FCK Newton per mm square. And as the modulus of elasticity of the concrete changes with the time, age, at loading, etc., and the modular ratio changes accordingly. Taking into the effects of creep and the shrinkage, partially IS code gives the following expression for the long-term modular ratio. And the long-term modular ratio, that is M is equal to 280 divided by 3 into FCBC, where FCBC is the permissible compression stress due to the bonding in concrete, and it has been given in a Newton per mm square as the unit. Next one, it is the Poisson's ratio. The Poisson's ratio varies between the 0.1 for a high strength concrete and zero point 0.2 for a weak mixes, and it has been normally taken as 0.15 for the strength design and zero point 0.2 for the serviceability criteria. Next one, it is the durability of the concrete. The durability of the concrete is the ability to resist its disintegration and decay. One of the chief characteristics that influencing the durability of the concrete is its permeability to increase the water and potentially deteriorate material, and the desired low permeability in concrete has been achieved by having an adequate cement, sufficient low water cement ratio, and by ensuring full compaction of the concrete and the adequate curing. Next one, the unit weight of concrete. The unit weight of concrete depends on the percentage of the reinforcement, type of aggregate, amount of voids, and it has been varies from 23 to 26 kilonewton per meter square. The unit weight of the plain and reinforced concrete are specified by the IS 456 are 24 and 25 kilonewton per meter cube respectively. I hope you understand this video. Thank you.